In this video, we'll talk more about updating variables in loops and how we can use loops to model the motion of objects. We've gone over how we can make a simple loop that changes the value of a variable. As we've mentioned before, we're not limited as to what variables we can manipulate in the loop. Here is a program that creates two spheres and an arrow, and that also uses a loop to calculate new values for a vector r by adding a constant amount to the x component each time. Let's add a print statement into the loop and to make sure that the vector r is being updated properly. Run the program and everything looks good. What if we wanted to use this vector r to change the location of the second cyan sphere? What we'd like to see is the cyan sphere moving across the screen every time that it gets a new position. What should we add to the program and where should we add it? So let's add a command inside the loop that creates a new sphere that has a position vector r. Will this change the location of the cyan sphere, making it look like it moves across the screen? Let's run the program and see. So we see a flash of activity that ends with a line of cyan spheres. If we add a rate statement into the loop, it will slow down the speed at which the computer runs the loop calculations. Writing rate 10 means that the computer will only do 10 calculations in 1 second. It looks like a brand new sphere was created every time through the loop. This actually makes sense since each time I go through the loop, there is a new r vector, and each of the sphere statements basically makes a new sphere from scratch at that new position without deleting the previous sphere. We wanted the display to have one single sphere moving across the screen. Let's think about what would be changing for that sphere. The sphere's color and radius would not be any different each time through the loop, so they don't need to be updated. The sphere's position, however, does need to change, and that's all we really need to do in the loop. So let's try only updating the sphere's position attribute. Since we've already named the sphere, we can just reassign the new r vector to the position of ball2 by typing ball2.pos equals r. This code takes a single object, the sphere named ball2, and changes its position to the vector r. Since r is the vector that we're changing each time through the loop, the sphere's position will change accordingly. Running the program, we see that this is indeed the case. Here we've told the object to change position by a set amount each time through the loop, which creates an animation as the object moves across the screen. In physics, we use fundamental principles to provide information about a system's motion. We'll use this information to update object attributes to create animations. When I first ran the program, before I changed the loop to create new spheres, the orange arrow pointed from the green ball to the cyan ball. This is no longer the case when the cyan ball starts moving across the screen. If I wanted the arrow to continue pointing from one ball to the other, what would I have to change about my program? Try to change your program to recreate this animation.